Hi guys, it's your science teacher here, back with another video. This time it is for you Key Stage 3 people, and this video is all on forces. And forces is such an important topic for everyday life. It governs nearly everything we do, from driving our cars, to walking to the shops, to even picking up your mobile phone. So without further ado, let's get on with this video. Let's start by looking at what a force actually is. And a force is a push or a pull which can change the shape, direction, or speed of an object. Forces can be split up into two categories. One which are touching and one which are not touching, which we call contact and non-contact forces. You're probably more familiar with contact forces, things that involve actual touching. For example, tension is a contact force. That is the pulling and stretching. That's a fancy word for stretching, is tension. You might have also heard of the contact force friction. And friction involves two materials rubbing against one another. And there is the reaction force. And a reaction force is basically, if you are standing on the ground, the reaction force is the force that the ground would put back onto you. We'll talk more about reaction force when we look at force diagrams in a second. But the second type of forces are non-contact force, forces that do not involve touching. You might say, well, how does this happen? Well, let's look at a few examples. For example, gravity. We cannot see gravity, but that force is acting on us as we speak. It's the force that pulls us back down to the earth, and anything that has mass has a gravity. Other examples of non-contact force include magnetism, and you have probably observed that when you put a magnet which has opposite poles together, they will attract each other even when they are not touching one another. This is a fantastic example of a non. So we saw the different contact forces, but let's look at one of them in particular, and let's look at friction. And when you have friction, you have an opposition to the direction that something's moving in. And the result of friction is usually some heat. Now, you've probably seen friction take place when you're ice skating. There is really low friction, and that is the reason why you slide so far. But there are also some useful things that come out of friction. For example, drilling holes requires friction. Without friction, you would not be able to dig any holes into the ground. It's the force that basically churns that ground up. And it's important to remember that friction does not just happen in solids. It also happens in liquids and gases too. But in liquids, we usually call it something different. We call it water resistance. And this shark is wanting to be as streamlined as possible. And that means that it wants to reduce the amount of water resistance that it has. And to reduce its water resistance, it has some special adaptations. It's incredibly streamlined, for example, and it contains fins that help it cut through the water faster. Fighter jets are the same. They experience air resistance. You wouldn't really think of air emitting friction. However, it does. And you might have felt that as you're running a race. You might feel that the air is hitting you in the face as you're running quicker. And you are actually feeling that air resistance, the force of air acting on you, pushing you back. And that's why fighter jets are designed in this way. In fact, some birds tuck in their wings when they're diving to reduce the amount of friction that is felt and increase their speed. Let's now look at how forces interact with one another. This is simply just a box resting on a table. But why is that box not moving? Let's look at how the forces are acting on that box. The first force we're going to look at is weight. That box is putting a weight force on the table. And that is what is stopping the box from flying away. Now that table is also putting a force back onto the box, and that is called the reaction force. And here the weight is equal to the reaction force because it is not moving. And these forces interacting with one another is called an interaction pair. And as long as neither one of them forces changes, it will stay still and exactly where it is. Just think of a boat at sea. The boat is putting a force on that water, and that force is its weight. However, that boat stays afloat. The weight is not the only force acting on that boat. Now, the force in water is usually not just called the reaction force, it is also called upthrust. And these two forces are balanced if the ship is not sinking. Not everything we look at is motionless, no, and still. We also look at things that are moving in physics. For example, look at these three cars. This car here, this first car at the top, is moving. And there's three forces acting on this, four forces, acting on this car. You have the weight and the reaction force of the road acting back on the car, the weight acting on the ground. But you also have the driving force of the car, which is moving this car forward. And you have the friction of the road as well, which is stopping that car. It's opposing the motion. Now, if this car is moving at a constant speed, these four forces will be in balance. The driving force will be equal to friction if it's going at a constant speed. However, cars don't always move at a constant speed. Sometimes they speed up. Now, when a car is speeding up, the driving force is much larger than the friction. The reaction force and the weight stay the same. The only thing that changes are the driving force and the friction. Now, if that car wants to slow down, this is the opposite thing that happens. The friction is now a lot larger than the driving force, and this will cause that car to slow down. We're now going to look at two very special forces. These two forces are called compressions, and we are also going to look at, and the compression force is the force you get when you squash something, and tension is when you extend something. Now, materials that like to return to their original shape are called elastic materials. And elastic materials will really try and oppose compressions or tensions. There are also rigid materials. Rigid materials, they will try, they will not be compressed or go under tension very easily. Sometimes you can get compressions and tensions happening simultaneously, which means at the same time. For example, look at this little bridge that I have set up here. Now this block, or this mass that's been placed on this wooden block, will have the force of its weight acting on it. And the force of the weight acting on it will cause a compression. So you've got compressions happening here going downwards. And because of the compressions, it also causes tension as I'm extending it due to the compression. And that's what's causing this deflection. In class, you will have observed the property of elastic materials. You'll have observed that elastic materials obey a law called Hooke's law. And what Hooke's law states basically is that the extension of a spring is proportional to the force applied on it. So here I have three different, here I have the same string but experiencing three different forces. So here there is no force added, so this is just the original length of my spring. And here I have a new length of my spring because of a mass. To work out the extension, what I'd need to do is I'd need to do the new length minus the original length. And that would give me an extension. Now, if I keep adding force and measuring my extension, what I realise is that my force increases at the same rate as my extension does, and that causes a straight line graph. Don't worry if you don't understand this, this is only for the higher tier students and can be a difficult principle to understand. Don't worry, some of my year 11s still struggle at it. When I've been talking about forces today, I've been very specific in making sure that when I've been talking about the force going down due to gravity, I've always called that weight and not mass. This is because weight is a force. And weight is equal to mass times by gravity. You may have not seen one of these before, but this is called a calculation triangle. And I use calculation triangles to be able to rearrange my equations in order to calculate the other things in that equation. So, the way you do that is you cover up the thing that you want to calculate. So, for example, if I want to calculate weight, I would cover up weight, and that would leave me mass times gravity on the bottom. Now let me try and do this with something else. Let me cover up mass, for example. Mass equals weight divided by gravity. What about if I wanted to calculate gravity? Well, gravity is equal to weight divided by mass. It's also important to remember the units of the different things that I'm trying to calculate. Well, weight is a force, and force is always measured in newtons. Mass is measured in kilograms, and gravity is measured in newtons per kilogram. So, your mass is in fact everything that makes up you, whereas your weight can change depending on the amount of gravity acting on you. That's why if you're wanting to go on a quick lose weight scheme, you should just take a trip to the moon, because of the fact if you go to the moon, gravity is a lot less there. Therefore, you will weigh a lot less on the moon. However, your mass will not change. You will still be made up of all the same things that makes you up. Your bones, your eyes, your hair, even your poo makes up you. And that is included in your mass. However, your weight would change if you went to a far out planet. If you want to gain weight, why not just head over to Jupiter? Jupiter has a gravity almost 3 times the gravity on Earth. Now, unfortunately, that is the end of the video, and I think I've covered everything in the topic of forces. I hope you liked the video, and please remember, if you do, drop it a like and please subscribe to the channel.